My poster is focusing on the development of a novel human shoulder simulator for cyclic testing of the rotator cuff tendons. The simulator shown here uses a cadaveric shoulder joint dissected down to reveal the rotator cuff tendons. Cord is then sutured to the tendon ends of the 4 rotator cuff muscles and the anterior and middle deltoids. The cord is then passed through the eyelets on the scapula to replicate the lines of action of the muscles. An actuation system is used to simulate the muscle contractions to perform abduction and flexion movements. The force in each muscle required for this motion is recorded. The motion and the resultant force in each muscle was measured and then compared to a bespoke computational model. This is an example of the results obtained from a cycle of the abduction motion. Each line on this graph represents the force required in one of the muscles during abduction and adduction. It can be seen that the force decreases during the initial phase and then plateaus as the joint locates its neutral position. The contribution of each muscle to the total force required at minimum and maximum abduction is given here. It can be seen that at 40 degrees abduction, the primary mover of the shoulder is the supraspinatus muscle, which agrees with results from literature. The values are consistent across cycles, as each muscle returns to a consistent value each time the neutral position is achieved. This novel human shoulder simulator allows for repeatable cyclic testing of the rotator cuff through a range of motions. It will be used to assess the effect of rotator cuff tears and the resultant change in forces within the joint, together with testing of different surgical repair methods. Thank you for watching. Please scan the QR code to see my full poster or visit at ESB.